Hello students. Welcome to the next session of Raspberry Pi and Embedded Linux Programming course. Linux is a multitasking, multi-user operating system. It is capable of running several programs in parallel. Each such program may contain several processes that run in parallel. Which means, in a Linux OS, several such processes are running at any instant. We learn about processes and how to monitor and manipulate them in this session. This is where we currently are. This is module 2, and we are having the process session from topic 1. This session aims to give you a practical understanding on how to create, monitor, and kill processes in Linux. Let's take a look at the objectives of this session. So in this session, first we introduce what a Linux process is and see a few shell commands related to it. Then we discuss how to create parent and child process using the fork mechanism. And finally, we discuss about zombie and orphan processes. So let's begin. What is a process? In Linux, whenever a command is issued or whenever an application is run, it creates or starts a new process. For example, when the command pwd is issued to list the current directory location of the user, a process starts. Each running task is a process. A program may contain several such processes, depending on the use case. Linux assigns a unique ID, known as process ID or PID, for each process. Though these processes appear to be running simultaneously, in reality, at a particular instant, only one of them is run. The scheduling of when these processes are to be run depends on the scheduler mechanism inside the OS. There are many methods of scheduling available. It's a vast topic. As far as Linux is concerned, it uses preemptive scheduling, which means the switching from one process to the next happens as soon as the time allocated to the process is over, no matter whether the task is completed or not. The switching from one process to another is known as context switch. Before switching to the next process, all the information regarding the previous process is saved. How to run and stop a process. A process can be run in two ways, either in the background or in the foreground. For example, consider this example code. What this code does is, it keeps on printing every 1 second. On running this code as shown here, it runs in the foreground. Which means you can issue the next command only when it completes and returns the prompt back. Whereas when the same program is run with an ampersand character at the end of the program name, the process is pushed to the background and returns the prompt immediately, so that other processes can be run from the terminal in parallel. I hope this clears the difference between running a program in foreground and running a program in background. Now let's see how to stop a process. If the program is running in foreground, hitting Ctrl+C on the keyboard, also known as interrupt character, will stop a process. But this won't work if the program is running in the background. For that, you have to use the kill command. First, we have to find the PID of the process we want to kill. Use the top command to find the PID. On issuing the top command, it will show all the processes running within the working environment of Linux. The output of the top command include lots of information that shows memory usage, CPU usage, and so on. This is one method of finding the PID. The command ps, also known as process status, lists all processes running from the current terminal along with their process ID. This is another method for finding the PID. So, after noting down the PID of the process, issue the kill command as follows. You can also kill a process by its name. Use the pkill command as shown here. Types of processes. Each application or command has a main program within it. This main program is known as the parent process. It is also possible to create new processes from a parent process. Such processes are known as child processes. There are two consequences for a child process when it terminates. It can become an orphan process or a zombie process, depending on when it terminates compared to its own parent process. If the parent dies before the child process terminates, the child process becomes an orphan. Immediately the Linux system init process adopts the child and does its cleanup after the execution is complete. Whereas, if the child dies before the parent terminates, the child process would continue to exist until the parent queries the exit code of the child. Such processes are called zombies. Therefore, a parent should always query the exit code of the child before terminating. If it doesn't, then the Linux system init process will undertake the cleanup. But that won't be immediately done. As a result, the process ID table keeps on piling up with defunct processes. This has to be prevented. We will see how it's done later. There is another class of processes known as daemon processes. They are system-related processes that handle service requests from other processes. They run in the background and wait for triggers from other processes it can work along with. For example, a printer task. Creating a process. Now let's see how to create processes in C. We use the fork routine for creating new processes in Linux. The main program is the parent process. From the parent, fork is used to create a child process. All the statements after the invoking of fork are executed twice. The output will be as shown here. There will always be two returns from a fork routine. One from the parent and the other from the child. When it returns from the parent, it returns the PID of the child. When it returns from the child, it returns 0. This return value can be used to identify the child process routines and thus create a separate branch of the main program. This is required if we are to run a separate set of routines inside a child process. This is shown here. Now if we have to run executable images as part of the child process, then we need to use the exec routine. There are many exec library functions. All of them basically does the same job with some minor variations. One such example is shown here. Here, the ifconfig command is run using the exec routine. You have to understand that the exec function replaces the calling process's memory with its own code and data. Here the calling process is the child process. Therefore, any statements beyond the exec function in the child process will not be executed. If the exec function was invoked without forking, then the main program memory would have been overwritten. Orphan process. Now that you have understood how to fork and create a parent and child process, let's learn how orphan process is created practically. Here the parent process exits before the child exits. The child process will exit only after 5 seconds. zombie process. Now let's see how a zombie process happens. Here the child exits earlier than the parent process. It will be cleaned up only when the parent exits. Until then, the child process will continue to exist in the system as a zombie process, consuming resources. So, how can we prevent the creation of zombies? We shall explore two methods here. In the first method shown here, the parent process waits for a specific child process to terminate. This way, the parent can collect the exit status of the child and prevent the creation of a zombie process. The wait PID routine is used for that. In the second method shown here, the parent process uses a signal handler for the SIG child signal. The signal handler calls wait system call within it. When the child terminates, the SIG child event is raised. On receiving the SIG child signal, the corresponding handler is activated, which in turn calls the wait system call. This, the parent can collect the exit status of a terminated child immediately and thus clear the process ID table. What's the difference between the two methods we discussed here to prevent zombies? In the first method, the parent has to wait until the child terminates. So it's a blocking method. In the second scenario, the parent can continue with its job without waiting for the child termination. When the child terminates, the signal is raised and handled. This is a non-blocking method. So that brings us to the end of this session. We learnt what process is and discussed how to run a process, kill a process, and track system processes using Linux shell commands. We then went on to create processes in C. We learnt about parent and child processes and also about zombie and orphan processes by doing practical exercises. For a detailed reference on processes, please refer the following link. The takeaway from this session should be a clear practical understanding on how to create, monitor, and kill processes in Linux using C. In the next session we discuss about inter-process communication. See you there. Thank you.